This question says to determine algebraically whether the functions are inverses of each other. So determining algebraically, that's where in the equation you switch x and y and then solve for y. And we want to find out, if we do that, do these equations match up? So what we could do is we could take, in part I, we could take the first equation, which is y equals 3x minus 6. We could switch x and y and solve for y. So we'd have to add 6 to both sides and then divide by 3. And then ask ourselves, does this match with y equals x minus 6 divided by 3? Are x plus 6 divided by 3 and x minus 6 divided by 3 exactly the same thing? No. So we can say in A, no. They are not inverses, because those equations need to match up in order for them to be inverses of each other. In the second one, there is a restriction in the domain in the first part. So they give us this equation, negative x squared plus 3, and then there's a comma and it says x bigger than or equal to 0. So this is a domain restriction. It means that we are not looking at the entire graph. We're only looking at the part of the graph when x is bigger than or equal to 0. So now algebraically, we still switch x and y, and switching x and y means that we would have x equals negative y squared plus 3, and we have to switch x and y in the restriction as well. So now we're looking at a new graph where the y value is bigger than or equal to 0. What does that mean? Well, solving for y, I can move the 3 over, multiply by a negative to get the y squared by itself, and square root. Now, when we square root, we normally have plus or minus out in front when we square root both sides. But this time, since y has to be greater than or equal to 0, the only one we would have is the plus. Does that make sense? And so our equation, our inverse, is y equals the square root of negative x plus 3. And our question is, does this match with y equals the square root of 3 minus x? Is the square root of negative x plus 3 the same as the square root of 3 minus x? Yes. So we could say, yes, they are inverses. How would we verify these answers graphically? Well, for A, if I were to graph both of these, the easy one to graph is 3x minus 6. I'll graph that one in purple. We have a y-intercept of minus 6, a slope of 3, so I would go up 3 over 1, up 3 3 over 1. And there's my purple graph. It has points. All right, so our video froze here, but for the x equals 3y, for this equation here, x plus 6 all divided by 3 equals y, we can change that to y equals mx plus b form by doing 1/3 x plus 2. If you graphed 1/3 x plus 2, and I'll do that in red, so we have plus 2, a slope of 1/3 means go up 1 over 3, that would be this line. So a couple of things. On our purple graph, just for one example, we had the point 0, -6, correct? If we did the inverse image, this point should match up as -6, 0. So the question is, did it work in this case? It appears to so far. But if we take another point on a red graph, for example, we have 0, 2. Oh, we were supposed to verify graphically if the two original equations were inverses, and what am I doing right now? It's the problem with flipping. I'm checking the one that we got. I'm not graphing this one, right? So it should be -2, not +2. I was like, they are matching up, but I wasn't doing the right one. If I did -2, sorry, that would take, let's start again. I started, my problem here right now, I graphed the purple graph, which matches up with this first equation. I should now graph the second equation, which is x minus 6 divided by 3. And what I started graphing was the x plus 6 divided by 3, which algebraically we know is the inverse. So I'm going to go back. I'm going to graph the x minus 6 divided by 3 and change this equation to y equals mx plus b form. That graph has a y-intercept of -2, a slope of 1/3 up 1 over 3, up 1 over 3, and looks like this. Our purple graph started here, went up 3 over 1, up 3 over 1. That was our purple graph. How do we know that these aren't inverses? One way we can see that they're not inverses is on the purple graph we have the point -6, 0. But 0, -6 is not on the red graph. If they were inverses, switching your x and y values would match up. Graphically, another way we can tell these are not inverses is if we draw the line y equals x. If you flip the purple graph over that line, does it match up with the red graph? No. If I flip the purple graph over, it would look like that. More or less. Actually, it would go through this point, so this would be better. So in this example, what they want you to see in part B is that you can figure out if something is an inverse algebraically by switching x and y and seeing if the equations match up, or you could check it graphically by graphing both of them and seeing if the points switch or if it's a reflection over the line y equals x. Questions for practice here are 7, 8, 11, and 13. And both 11 and 13 are just worded a little bit different and they'll make you think.